Good day guys, how are you? My name is Naleen and I'm an IB teacher, and you guys did your IB exams last month, right? So I'm sure you guys are wondering how well you did in your exam. So I thought I should be sharing my answers with you and explain how I get into each answer so we can clarify some mistakes, right? Alright, let's start from question number 1. This question is about the area of a circle, right? But we are HL, so finding an area of a circle is not the problem. Problem is how to find the uncertainty of the area. They say the radius is 10 plus or minus 0.5 centimeter. Alright, so how to find the area with the uncertainty? Area is pi r squared, pi 10 squared, 314 square centimeters. Use then now let's think about area equation one more time. Pi r squared delta a over a. Think about this as pi. If you are confused, think about it as pi r times r. Then it's easy to you can take it as a multiplication of two variables. Okay, so this pi disappears in the error calculation. Plus or minus 2 comes at to the front, delta r over r, right? So delta a equals plus or minus 2 delta r over r. I write area cross multiplication again as pi r squared. If you look at this one, you will get 2 r delta r times pi. If you do the calculation, you will get 31 centimeter squared. So area can be written as 314, the value, plus or minus 31 centimeter squared, the uncertainty, right? This is the answer. So answer for question number 1 is D. This question is about proving a proportionality in two different situations. Now they have given you the maximum and minimum gradient lines. So where's the best fit line? Best fit line is obviously in between these two lines, right? Same here. This is the best fit line. Now what is proportionality? Proportionality can be explained in two different ways. Mathematically, you can write y is proportional to x. Graphically, on a graph, it should look like this. I am talking about here. Proportionality means the graph should be a straight line. And what is the second condition? It must go through the origin. Very good. Now, if you look at these two situations, this one satisfies what you want to see. It is a straight line. It goes through the origin of the graph. What about this one? The graph we expected. Hold on, let me draw it better. Okay, very good. Now, the graph we expected is this blue line, but graph we get is the red line. What does this show? This shows that, hold on, sorry again, all the readings have moved by a certain number. What does this ring a bell? Of course, this is called a systematic error. No, so graph P, this is the P, definitely shows a systematic error, right? So answer has to be, they ask which graph shows systematic error, which graph shows bigger uncertainty in gradient. So graph P has larger systematic error, right? And this. So answer has to be A and C. Now let's think about graph Q. The uncertainty of the gradient is the gradient of this one, gradient of maximum line minus gradient of best fit line, right? This is the uncertainty. Obviously the the gradient values, see, one is like this, the other one is like this. There's a big difference in the gradient. But if you look at this left hand side graph, the gradient is almost same. So higher gradient uncertainty is with Q. This is the answer. Let's go forward. This question. Something is sliding down an inclined plane, right? The thing is, if it is falling down, it's very easy. We know acceleration is 9.81 ms minus 2 downwards. That's easy. But the problem here is we don't know this angle. We know there's an acceleration downwards, but but we don't know the value of acceleration, right? Now what do we know? But one thing we know is the acceleration is constant. What I do is I write time equals 0 seconds to time equals 1 second. I write this direction to along the inclined plane. S equals ut plus at squared over 2. I'm just trying to find the distance it travels in the second. Hold on, that's the point. During the next second. So we are only focusing about the second. But the process is like this. So let's say S1 equals starting from rest, acceleration in first second to actually this displacement is given. They say in first 1 second it travels 1 meter. So from there I can get acceleration as 2 ms minus 2. Put the numbers into equation, you will get it. Now let's think about time equals 0 seconds to time equals 2 seconds all the way. I write the same equation. S equals ut plus at squared over 2 down, and let's say S2 is 0 plus acceleration we know, right? 2 for 2 seconds divided by 2. This gives this distance traveled from 0 to 2 is 4 meters. Now is the trick. Delta S, difference in these displacements is 4 minus first 1 second is 1 meter, until second 0 to 2 seconds it is 4 meters, 4 minus 1, 3 meters is the distance traveled during the next second. So answer for question number 3 is C. Projectile motion, they want to know how much is this height. Time here is t and total time is capital T. The problem is, if you are going in the projectile motion, let's say this is u, and if I can break this one into two parts, right? One is horizontal velocity, one is vertical velocity. If this is theta, this is u cosine theta, this is u sine theta. By practice, I know normally I should write to find the distance. In best application in this case is S equals ut plus half at squared. I'm writing for the let's say from O to A and B. O to A. So H equals u sine theta times minus gt squared over 2 y minus, because look, I wrote equation upwards, so I have to follow the positive direction. So acceleration is down, that's why I put minus here. This equation is good, but this is not how they want to see this. The problem is, what is this u sine theta? It is not in the answer. So let's think about for O to B or whole motion. I do the same. I write again S equals ut plus at squared over 2. So total displacement at the end is 0, right? So u sine theta, because we are talking about vertical motion, total time is capital T. Again half gt squared y minus, because acceleration is down. That's good. Now I have u sine theta I can write u sine theta in terms of g and capital T, right? So u sine theta equals g t square t over 2. Why? Because capital T cancels out. Now my job is only to apply this one here. So h equals u sine theta g t over 2 times small t minus g t squared over 2. So h equals g and small t and over 2 is common. So this becomes t minus t. We came this far, but you know the bad news? Bad news is if you are in a hurry, you can make the same mistake I did when I was looking at the questions by choosing C. Be careful, this is capital T. So you have to choose the right answer. Be patient and choose D. We need a diagram to understand this question. Let's think you have two different balls. One is hollow and one is solid. Now, first thing to understand, solid or hollow does not matter. At the beginning, it only has mg force. Why? Because friction force depends on the speed. Fd, drag force, depends on the speed. If there's no speed, there's no drag force. So first thing is acceleration at this point is mg over m. Acceleration is force divided by mass, right? So at the beginning it has to be g. Now let's think when it goes forward, when it falls down, the mg never changes, and mg stays the same, but F drag keeps increasing because speed increases. So at terminal speed, actually this is mg and F drag can balance mg, right? So I can write an equation like mg equals kv naught at terminal speed. So V naught equals mg over k. K is a constant for the ball. So if m is bigger, V naught is bigger. So higher the mass, higher the terminal speed. So let's see what they do. Now they are dropping a hollow metal ball. So obviously hollow metal ball, mass is small, V naught is small. So two things we have to understand. The hollow ball must be here because it has to reach a lower terminal speed. But is answer C or D? The problem with answer D is it shows at the beginning. See, at the beginning the solid metal sphere has acceleration as g, right? The gradient is that. But this one is different. No, they have to start from g equals 9.81 acceleration. So only C gives the correct answer. C shows you are starting from 9.81 and you are reaching a lower terminal speed. So question number 5, answer has to be C. This is about Newton's third law. Every action has a reaction force, right? So this is about a rocket being fired into higher atmosphere. Let's draw the earth here. Alright, and let's use different colors. This is the weight of the rocket, mg. Of course, the thrust from the engine is bigger. That's why rocket is accelerating upwards, right? I used a blue color for the thrust. It's bigger. Alright. Now the thing is, where's the reaction force of this force? To answer that question, you should ask, who gave this? From Earth, right? From Earth on rocket. So the reaction force must be from the rocket on the Earth. So I will mark this one. See, equal and opposite force F2. Now you can ask, What about this one? Because this is coming from the air, because exhaust gas is being pushed down by the rocket, so the same force should act on the gas by rocket. So these are the answers. So I repeat, the F2 must be on the earth. So let's start with F2. For it's not about the gases. Gravitational force of rocket on earth, that's good. Not about the gases, gravitational force of rocket on the earth. So answer has to be A, B or D. Now let's think about the force F1. Let's think about F1. It has to be, the reaction force is the force from the rocket on the exhaust gas. Force of rocket on exhaust gas, that's right. Gravitational force, no. F1 is not a gravitational force, it's a thrust. So answer for question number 6 is B. They say there's a book on a table. The table is able to roll along the floor. Now we don't want this book to slide on the table while table is accelerating. So what does this mean? It means we have to first understand how this book moves forward. First the table moves forward, right? So the book gives a friction force on the table. So by Newton's third law, that same force should act on the book by the table. Let's say it is F. As long as this force stays below the maximum friction force, the book is stationary related to the table. Of course, they both are accelerating forward. That's not the point. Relatively, they are stationary. So the force should stay below maximum friction force. So F maximum is mu r, right? Should be the MA. So mu r is mg is ma. This one cancels. A equals mu g. Question number 8. Now this looks confusing, but actually it's not as hard as it looks. It's let's say you have two blocks, right? One is 1 kilogram, the other one is lighter, so it is 0.25 kilogram. 1 kilogram, 0.25 kilogram, and both springs are the same. This is 100 Newton per meter spring constant for this one also, and extension is 0.1 meter for both of them. Now idea is you have to write conservation of energy. Elastic potential energy is half kx squared, will change into half mv squared in both these two situations. From there I can cancel this. V squared equals k over m, right? K dot x squared. So V equals, if you check this one, k over m square root times x, right? Now for 1 kilogram mass, I substitute values. K is 100. For 1 kilo, mass is 1 times 0.1. This is in the square root, this is outside. If you look at this one, you will get 1 meters per second. For 0.25 kilogram, same thing. V is spring constant, same, 0.25 square root times 0.1. The extension is the same. You will get 2 meters per second. So one is 1, other one is 2. Let's say block X is 1 kilogram block. This is 0.25 kilogram block. So this has to be 1 kilogram, has to be 1 meters per second, and 0.25 kilogram should be 2 meters per second, right? All right. Now, what is true for an ideal gas? What do we know about ideal gases? We know PV equals nRT is true for an ideal gas, or theoretically by kinetic theory, PV equals 1 over 3 mnc squared bar. But this is not what they care about in this question. They care, the exam wants to check whether you know how to combine Boltzmann constant. This is called Boltzmann constant and ideal gas constant. And there's another one, not N, Na, Avogadro constant. This question is only about whether you know how to combine these three three constants. So let's think about it. nRT. Now we know number of moles is number of molecules divided by Avogadro number, right? So I start nRT means N over Na R times T. N R over Na times T. The idea is whether you know what is this constant is. R divided by Na is actually Boltzmann constant times time. So if you can just start from here and come here, that's all what they want to see. Have a look. First question, first answer A. nRT equals N Kb Boltzmann constant times T is the answer. Which assumption is part of a molecular kinetic model of ideal gases? Okay. What do we know about ideal gases according to our molecular theory? We just imagine every gas to be made of many identical small molecules which are far apart, right? So let's check. The work done on a system equals change in kinetic energy of the system. What? Work by first law of thermodynamics. Says heat given is increase of internal energy plus work done. What I mean is you don't need to know this one, but it has three variables. This one reduces it to 2 and it does not work. Second one, volume of gas results from adding the volume of individual molecules. No, the volume of a gas is about the volume in between. These are much bigger. This is the real volume of a gas, not the molecule of volume of the molecules. Gas is made up of tiny identical particles. Are they tiny? Of course. That's why volume is considered to be the volume in between molecules. We don't even consider about the volume of molecules in an ideal gas. Identical? Yeah. These gas molecules are same size, identical, but random motion. Is it true? Let's have a look. Number of molecules and speed graph for any gas is like this. This is a bell curve or normal distribution, right? So of course random. Some of them are very fast, some of them are very slow. So they are in random motion. So this answer C is right. All particles in a gas have kinetic and potential energy. No, to get potential energy, no intermolecular forces. So you can't have potential energy. So answer D is wrong. This is about you have water and you change it into ice and you keep taking heat out of this one. So you make ice at even lower temperature. This is the process. So the thing is, specific heat capacity of this one is twice compared to specific heat capacity of ice. Now if you look at this cooling graph, this temperature, this is time, and this is temperature. This specific heat capacity, how is it being represented on this graph? We know Q equals mc delta T equation, right? So for given same amount of heat for same mass, if the specific heat capacity is large, the temperature difference will be smaller. So this means specific heat capacity is higher, means gradient of this graph. Gradient represents how fast temperature changes. The temperature will not change much if the specific heat capacity is larger, right? So that's the idea. Now let's go back. This gradient on answer A and this gradient are the same. No. Same problem here. These two are the same. No. Now this answer C, this gradient is bigger. No, this gradient should be smaller because this is bigger. So gradient should be smaller. So this also wrong. This gradient is, have a look, answer B, this gradient, and the other part ice has higher gradient. And that makes sense. So very good. Answer B gives what we know. In simple harmonic motion, you are moving between 2 points, right? Middle point is called equilibrium point, right? Now let's actually this is just memory, right? I mean here displacement is 0. Here displacement is, if you take right hand side as positive side, this is minus amplitude. This displacement is amplitude. Let's think about velocity. Velocity is maximum at the middle. Velocity is 0 because it is turning back. Velocity is 0. Let's think about acceleration. Acceleration, do you know any equation? Minus omega squared x, right? So x equals 0. Acceleration is 0, right? So acceleration here is 0. Acceleration is maximum. Acceleration is maximum. You can say, but acceleration is in different direction. No, we are just thinking about the number. So if you look at this one, velocity is 0, but other two are not 0. But if you look at middle point, displacement is 0, acceleration is also 0. So obviously displacement and acceleration both can be 0 at the same time, right? So displacement and acceleration can be simultaneously 0. Answer is B. This is about simple harmonic motion and wave motion. Simple harmonic motion has a displacement time graph. What can we get from that graph? We can get the period. Peak to peak gives us the period. What about displacement and distance graph for the medium? So 2 points, these 2 points are in phase points. So you can find wavelength from this. Now they ask about speed, right? V equals F lambda, but we know F equals 1 over T. So V equals 1 over T times lambda. Now you have to write this time period and wavelength in their symbols. So time here is PQ, right? So I write 1 over PQ times lambda is RS. So RS over PQ is the speed. So this one, no, RS over PQ, answer is C. Let's say we have glass. Let's say this is a glass and we have some water on top of glass, right? Okay, glass has refractive index 3 over 2. This is water has refractive index 4 over 3. Now a light wave comes and hits the interface between them. This is the normal. And at critical angle, the light wave will move between the two mediums or through the interface, right? Now they ask about this angle. Doesn't matter as long as the light is trying to refract, we can write Snell's law, right? So what is Snell's law? N1 sin I equals N2 sin R, right? So N1 is 3 over 2 sin C in this case equals 4 over 3 N2 sin 90. Why? Because the angle is 90. From there I can write sin C equals 4 over 3 times 2 over 3, right? Sin C equals 8 over 9. You can find C is sin inverse 8 over 9, right? 8 over 9, there's only one answer, Answer is D. Malus law is about polarization, right? This is where your sunglasses come into the explanation. Alright, first thing we have to understand, the first polarizer reduces the intensity into half. 320 watt per square meter. By first polarizer, it will change it into half. Okay, I made a thinner line here. Coming out is 160 watt per square meter. Now second analyzer, how much? Now it is coming to this analyzer is 160 watt per square meter, right? Analyzer, how much energy or intensity comes out depends on the angle, this angle between these two polarizing axes, right? This angle is, they say, 30. So here let's say this I dash is I cosine squared phi. This is called Malus law, right? So let's do the calculation. I dash is incident intensity is 160, cosine squared 30. They gave you cosine 30 is square root 3 over 2 squared, right? 160 times 3 over 4, 120 watt per square meter. Boom. Answer is A. Question number 16, they say there are 4 charges. On the left hand side you have negative charges, on the right hand side you have positive charges, and you have a positive charge at the center. They ask what is the resultant, hold on, they ask the net means resultant electrostatic force. Alright, let's do it. This negative charge will attract this positive charge particle towards him with a stronger force, because this force depends on distance squared but in an inversely proportional way, right? So, and second charge will also attract this one to the, let's say, kind of towards that charge, but with a smaller force. Why? Because it is further. Now let's think about the positive charges. This positive charge will not attract this one, it will push this one away. See, on this line it will push, and this charge also will push, right? Now if you look at this one, this is very symmetrical, right? These 4 forces. So what happens? They will cancel out vertically, they will add up into horizontal direction. So the net force is will be into your left. So answer has to be D, dog. It's better if you draw two circuit diagrams for this situation. You have a lamp, then in second situation you have 2 identical lamps connected in series. Now they ask about the potential difference across the first lamp. Let's say this is lamp X. What's the potential difference? Let's put numbers. 12 volt. Of course 12 volt comes here, no internal resistance. This 12 volt in second situation it breaks into 6 volt. So potential difference obviously has decreased, right? So potential difference has to be decreasing compared to first situation. Now let's think about power output. What is electric power? VI or I squared R or V squared over R, right? Let's think about, let's pick this equation. The reason is I want to think power in terms of the resistance of the total resistance of the circuit. Power equals V squared over R. First situation, power in second situation is V squared over 2R. Obviously this is smaller because resistance is higher, power goes down. So total power they are talking about, output power of the battery, whole circuit, has to decrease. So answer for this one has to be A. To start with, just forget about this voltmeter. Now actually I can draw the same circuit in a way. I can draw like this, right? Now this is 3 volt and let's say according to this picture, this is, hold on, this is 2 ohm, the other one is 1 ohm. This one is 1 ohm, this is 2 ohm. Very simple, parallel circuits, right? So this is 3 volt, this side is 0 volt, and this is 3 volt. So this potential voltage across this 1 ohm has to be, by potential divider circuits, this voltage has to be V equals 3 times 1 R1 plus R2, 3 1 volt, right? Similarly, this one should be, voltage is 3, 2 plus 1 3 is 2 volt, right? 1 and 2, potential difference between them, so is 2 minus 1 volt. Answer is B. They ask the force on one side of the coil, I mean section XY. Yes, they are talking about the force on this wire, how it changes with time. Looks tough, right? Alright, let's think about it. This now let's just imagine this coil is rotating into clockwise direction because of there's a force. Okay, we know that force is BIL. Because of this force, now let's think this coil has turned by 180 degrees, like 180. Now this blue line, blue wire is now here. Okay, but the problem is, if the force is still into the same direction, BIL, this coil will not rotate. This will go clockwise and come back anti-clockwise, go clockwise, come back anti-clockwise. This is not what we want a motor to do. We want it to keep on going. So what should we do? We want this force to change the direction when it turns by 180. So through this we can understand one condition is this force with time, or you can say with the angle, should go from positive to negative, like something like this. We don't know exact shape, but we know it has to change from positive to negative direction, or left to right, or up to down. It has to reverse the direction. That's one condition. Look at these answers. So we can remove these two, right? They don't reverse the direction. B and C I remove. Now let's go to the second part. Now let's think this coil has turned by some angle, but before that let me draw the magnetic field. Magnetic field is parallel to the plane of the coil, but now coil has turned. How? Coil has turned like this, okay? Now let's think this angle between these magnetic field lines and this and the coil. Hold on, sorry, this angle, let's think this angle is theta. So this magnetic field, you can break into two parts. What are those two parts? We can break it into, let me use a different color, this side parallel to the coil and perpendicular to the coil. Hold on, that's not a good drawing. Let me draw it. Okay, this is B sine theta, this is B cos theta. So that force F equals BIL is when the theta is 0. Here it has to be, real force is B cosine theta part only, IL. Why? Because this part is only important part. Based on that, again we can understand this force. Now omega is theta over 2t, so I write F equals B cos omega t times IL. What is this? This is a cosine graph, right? So with time this force has to go in a cosine graph. Very good. So it should be something like this. So answer has to be D. It is not some kind of jerky motion like boop, pop, boop. It's not like that. It's a smooth rotation, right? So of course answer has to be D. A satellite is orbiting Earth in a circular path at constant speed. Okay, let's draw the first the orbit and the Earth, and here is our satellite. So what are the forces? It has G capital M small m r squared force. This is gravitational force. So resultant force is, of course, there's only one force, it is the gravitational force, right? And whatever the net force is, F net is always equal to m times A. It does not depend on this situation, it's always true. So part 2 is also right. Third one, and as this satellite is not moving out of the orbit, it is not falling towards the earth, so of course this F net force has to provide the centripetal force. That's why it is on the orbit. Otherwise it has to either move out of the orbit into a higher orbit, or it has to be moving towards the earth. None of this happens, means this gravitational force or net force provides centripetal force. All three are correct. So answer has to be D. An astronaut is orbiting the earth. Again, I will draw the picture. Why he feels weightless? The thing is, yes, he has G, M, let's say his mass is m naught, r squared force, or his mg force. But this has been used to provide mv squared over r. That's why if I draw the guy like this, the two forces is, one is mg, one is r. As r equals 0, because this has been already used, mg has been already used, r becomes 0. This is called weightless. So what are the answers they say? Astronaut is outside the earth gravitational field of the earth. No, what I mean is earth's gravitational field extends to the infinity. If I draw, considering earth as a point mass, earth's gravitational field strength keep on going forever. So space station is somewhere here, or satellite is somewhere here. It is not zero gravitational field place. Acceleration of the astronaut is the same as the, okay, let's leave it. Spaceship is traveling at a high speed tangentially to the orbit. Force is not related to speed, so it is not about speed. Gravitational field is 0. Again they are saying like part A, the force is 0, so answer has to be B. When white light is emitted from a hot filament lamp, this is lamp's emission spectrum. All the colors are coming. But then what happens? Let's say I will draw the lamp here, and then it goes through a hydrogen gas, or any gas, doesn't matter, low pressure gas. What happens? Some of these photons will be absorbed by this gas. So in the energy level diagram of that element, an electron can absorb a photon and go higher. So this photon will be missing from the emission spectrum. So what you get at the end is a bright colorful background with dark lines. So lines has to be dark and background has to be colored. So answer is D. Question number 23, I think, is kind of challenging question for most students. 3 statements about electrons are: electrons interact through virtual photons, electrons interact through gluons, electrons interact through particles W and Z bosons. Alright, to understand this question, first we have to understand the standard model. A small idea about a standard model. Standard model, guys, is the periodic table of particle physics. We remember there were 6 quarks, right? We don't need much information about them, but we remember quarks. And then we have 6 leptons: electron, muon, tau, and 3 neutrinos: electron, neutrino, hold on, muon, neutrino, tau, neutrino. But these 6 leptons, I will write them, These are called leptons. And then we have four groups of force carriers, or you can call it gauge bosons. These are the ones who create the force. First one is gluon. This is responsible for strong nuclear force. Second one is a photon. Photon is the one who is responsible for electromagnetic force. The other one, W plus or minus, I mean there are three bosons together, W plus, W minus and Z boson. These are responsible for weak nuclear force. The last one is actually has not been detected yet. This is called graviton, gravitational force. The question is, they ask all about electrons. Leptons have a special quality. They experience They experience weak nuclear force. Of course, they experience electromagnetic force. Why? Because they have charge, but they don't experience strong nuclear force. So let's go back to the questions. Do they interact through virtual photons? What they mean is, do they experience electromagnetic force? Yes. Do they interact through gluons, means strong nuclear force? No, that is not for leptons. And electrons interact through particles W and Z. What I mean is, do they experience weak nuclear force? Yes. So these two are right. Second one is wrong. So you should say the correct answer is 1 and 3. Answer is, for question number 23, answer is B. This looks tough, but actually this is a pretty simple question. They say uranium 235-92 absorbs a neutron, changes into a barium, nuclear number or mass number is 144 and atomic number is 56, and krypton nuclear number is 89, proton number is 36, and we don't know how many x number of neutrons. Okay, let's check quickly. This side is 235, 1 plus 1, because we know mass number has to be conserved, 236. If you look at this one, 144 plus 89, 144, 89, 233. So 233 plus x. So x has to be 3, right? It means there must be 3 neutrons. So answer is D. A radioactive nucleus X decays into a nuclide Y. The graph shows the variation with time of the activity A of X. X and Y have same nuclear number. That's the tricky part. X and Y have the same nuclear number. What type of nuclear reaction gives a daughter nucleus which is this which has same nuclear number? Let's think. X, A, Z. If this becomes by alpha emission, this becomes A minus 4, Z minus 2. That's not good because it changes nuclear number. Now let's think about X, A, Z changes into something plus beta 0 minus 1. Randomly I just thought, what about beta minus? Then this becomes Y, A, still there, A, and this becomes Z plus 1, right? So it doesn't matter, A has not changed, right? Similarly, X, A, Z, Y, A, Z minus 1 plus beta 0 plus 1 plus electron neutron. Here it is electron anti-neutron. I know I am a bit too fast, but the point is these two reactions, beta minus and beta plus, actually does not change nuclear number. So this must be a beta minus decay. Let's say beta minus emitter. Okay, answer has to be somewhere between C and D. Now second thing they ask, what is the half-life? Half-life, let's discuss about half-life. You can explain half-life in two different ways. One, number of parent nuclei or good nuclei, let's call them good nuclei, becomes n naught over 2. That time is called half-life, right? Or you can say activity becomes half of initial activity. That time is called half-life. So activity here starts and it becomes half in time how much? 2t. So answer is D. Question number 26 has two keywords. What is that? Photovoltaic cells and heating panels. That's enough. If you read carefully, photovoltaic means it's about voltage, right? Obviously, photovoltaic cells changes solar energy or radiation energy of the sun into voltage or electric energy. And heating panels, obviously it gives away the answer actually. Heating panels changes solar energy, basically IR changes into heat, or you can call it thermal energy. That's why we use photovoltaic cells. We use this one to produce electricity. We use this one heating panels. What do we use them for? To produce hot water for the apartments mainly. So let's check. Photovoltaic cells produces electric energy. That these two are A and C are right. Solar heating panels should produce thermal energy. So answer is A. 3 statements about fossil fuels. There's a finite amount of fossil fuels on Earth. Of course, that's why they are expensive, because if we had unlimited amount of fossil fuels, there won't be wars, there won't be friction among communities if we had unlimited energy, right? So we definitely don't have fossil fuels unlimited. The transfer of energy from fossil fuels increases the concentration of carbon dioxide in the atmosphere. Of course, fossil fuels, what we do is we take fossil fuel, we burn, and we convert that into heat, and then we use it for our energy consumption. So this one byproduct, carbon dioxide, comes. So that's also true. The geographic distribution of fossil fuels is uneven and has led to economic inequalities. Of course, think about Middle Eastern countries. They are quite wealthy because of oil. Think about any other country, like let's say Sri Lanka. They don't have oil, so there is a economical disparity between countries. If you have oil, if you have a considerable amount of oil, you are automatically wealthy, right? So this is also right. So I pick answer D. It says, the question says, the age of the earth is 4.5 10 to the power of 9. First thing to understand is 10 to the power of 9 is a billion, right? So age of the earth is 4.5 billion years. Then they ask what area of physics provides experimental evidence for this conclusion. Okay. Now this one I will highlight again. This table I got it from the internet. It is half-life and decay constant information for different materials. Example, uranium has the biggest half-life of 4.5 billion years, and lithium has very short half-life, extremely short half-life, 10 to the power of minus 20 seconds. Okay, uranium. Let's focus on uranium. Uranium has 3 isotopes. One, uranium-238. The other one, uranium-235. The other one is uranium-234. This is important because this is what we used for fission reactions in the power stations or even nuclear bombs. But my target is to discuss about this one, uranium-234. Actually, it has a decay reaction. It breaks into thorium-234, 90 plus alpha-2 and alpha-4-2. Half-life of this reaction is 4.5 billion years. Now let's think. You guys go for extraction of uranium. You find a cube of uranium. after purifying it with other dirt and soil and everything is taken out, you notice something interesting. This one has uranium-238, but it is only 25%. Okay, the 75%, just imagine 75% is thorium. What does this tell to you? It has 25% uranium-238, thorium is 75%. I know there are more in the chain reaction, maybe thorium also has changed into something else, but that's not the point. Non-uranium part is 75%. It means I will write here uranium number of nuclei has changed into half, and then N0/4. This means 25%. How much time it needs? 1 half-life, 2 half-life. Then you can definitely say, okay, here it has gone 2 half-life. Time is roughly 2 half-life. So age of Earth must be more than 2 half-life, 4.59 billion years. Like that, you can develop an argument based on how much uranium-234 is remaining in a sample. Good news is how actually extra information, age of Earth is actually 4.5 billion years, and this is reached through observing half-life and remaining part of those radioactive or fission elements. So radioactivity is the secret weapon to find the age of the universe. Simple pendulum has a period T on Earth, simple taken to the moon, gravitational field strength is 1/6. What is the time period of pendulum on moon? Okay, if you check the data booklet, it actually gives you period of a simple pendulum, this one. So let's write this equation for Earth. T equals 2 pi L/G. Let's say for moon, let's think this one as T dash, 2 pi L/G/6, right? G/6 is 6 times weaker. So I can change this one, 2 pi L/G square root times square root 6, right? But this number, if you look at this one carefully, this one is this previous value, right? So T dash is T times square root 6. Answer is A. This is a pretty tough question. Let's start with they say in 2 different experiments, white light is passed through a single slit and then is either refracted through a prism or diffracted with the diffraction grating. The prism produces a band of colors from M to N. The diffraction grating produces a first order spectrum P to Q. Okay, let's start with diffraction grating. What do we know about diffraction grating? Let's say this is nth order, okay? Nth order. And the angle from the 0th order or central maxima is theta. We know this equation, it is in the data booklet. D sine theta is n lambda. So for a given order, for given grating with the given slit width, sine theta is proportional to lambda, or you can say sine theta and theta are proportional, not proportional. When theta increases, sine theta increases from 0 to 90. So theta is, you can think theta increases according to the wavelength, right? So but we should know violet, indigo, blue, green, yellow, orange and red, right? This one is the highest wavelength, so highest angle will be for the red. So I will draw this one here. This is the diffraction, sorry, let me use a different color. This is the diffraction grating and the colors will come, and red will go here and actually violet will be somewhere here. So M and N has to be violet, and they are talking about blue, right? This is blue. Okay, so in this case this is the first answer. So let's check in M and P and Q. P has to be red, So answer has to be either this or this. Now let's think about the prism. Prism, actually you can just use your memory. Dispersion of light, I mean light is breaking into different colors. We should know red is on the top and violet is on the bottom, or blue is below than red. Based on that knowledge itself, you can say M is red. So M is red also. So answer is A. Guys, question number 31. It is about Doppler effect, but actually it is more about V equals F lambda, and whether you understand how these three variables are changing when a source, wave source like car, honking and moving towards an stationary observer. So what do we know about Doppler effect? We know if a car or any other wave source is making a frequency f naught, the frequency the observer hears, let's say f dash is given by f naught, speed of the wave minus speed of the source. So this is bigger than f naught, that we all know. So f dash is bigger than real frequency. That is no problem. So we can quickly mark this as correct. The problem is, now we understand this one is increasing. What we don't understand is about the speed. Speed is the tricky point here. Now let's think about I am talking about sound waves, okay? Waves. Speed of sound wave in air is given by gamma RT over M. Don't be scared, not in the syllabus. But we always understand the speed depends on the medium. Something about, let's say example here, temperature or molecular mass, blah blah blah, it depends on the medium. But there's another point about speed. Perception of speed depends on observer's motion. Example, what does this mean? Let me give you a very simple example. Let's think there's a car coming towards you at a pretty high speed, let's say 25 meters per second. Now if you are staying here observing, you will see, yeah, it is coming at 25 meters per second. But what if you are running forward, at 10 meters per second, you will say the car is so fast, it is coming at 35 meters per second, right? Vice versa, if you are running away, you will say it is 15 meters per second. What does this mean? Your perception of, or your relative velocity of car depends on whether you are moving or not. So in this example, it's very important to understand the observer is stationary. So the tricky part is to understand that the speed does not change because you are not moving. So the speed is the speed of sound in the air, 330. So now the question is, if frequency is increasing, if speed does not change, what should happen to wavelength? Obviously this has to decrease, right? Alright, let's go to third option. The speed of the sound received is not affected by the motion of the train. Of course, right. Why? Because you have to move. Either you have to move towards the source or away from the source if you want the speed to your received speed or your perception of car's speed to be changed. Now second one, wavelength received is longer than the wavelength. Oh no, wavelength is decreasing, right? No, it's not longer, it's changing but decreasing, not longer. It should have been shorter. So this is wrong, these two are right. This is basic knowledge, the frequency blah 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 we know from Doppler effect. Now we understand if you don't move, the relative velocity does not change. Based on that we can get third one as wrong. So answer is 1 and 3 is correct. Answer is B. I will not read the question. You guys have read the question. It's about electric field strength and electric potential at this midpoint, which is equidistant from all these 4 points, right? And so the point is, we write, let's say, electric potential equation K Q over R. Electric field strength is K Q over R squared. The most important thing is to understand is electric field strength is a vector and electric potential is a scalar. That's it. Let's think about electric potential. So I'm writing here electric potential. Total electric potential. You don't have to think about directions. You just add them. Equals K Q over R. K Q over R. K minus Q over R. K minus Q charge is minus over R. You see, 2 minus charges, 2 positive charges equals magnitude. So that you will get 0. That's pretty simple. But when it comes to electric field strength, this one you have to think about direction. What is electric field strength? It is the idea when you place positive 1 coulomb charge at this center, the force on that charge part, 1 coulomb particle. Okay, this minus charge will pull you this way, right? And this minus charge will pull you this way by equal force. Why? The distance is same, charge is same, so they will cancel out, right? Now let's think about positive charge particles. This one will push you out because you are also positive. This one also will push you out by equal force. Why? Charge and the distance are the same, they will also cancel out. So how much is the electric potential, electric field strength here? E total is 0, no force. So electric field should be 0 and electric potential also should be 0. So answer is A. Again, they are asking about electric potential and electric field strength. Okay, let's look at it again. V equals K Q over R. E equals K Q over R squared. Okay, I start with with V. Let's think about dV over dr. You guys know differentiation, so E equals d over dr K Q over R, right? I will take K and Q out because they are constants. D over dr, I take R up, so R minus 1. So this ends up minus K Q over R square. This because this minus 1 comes to the front, right? But if you look at this equation, K Q over R squared is actually this electric field strength, right, numerically. So I can understand, so dV over dr is minus electric field strength, or electric field strength is dV over dr minus. This is the gradient of this graph, because the graph is, this is potential and this is distance. So this is the minus gradient should give electric field strength. This is the idea. The negative of the gradient of the tangent at S gives the electric field strength. So answer is D. Question number 34 is about transformers. Actually, transformer does not need a iron core. It basically needs 2 coils. Let's say this is a step down transformer. Why? This is secondary coil, this is primary coil. Primary coil has, in my picture, primary coil has more turns than the secondary coil. But point is, if you have an AC power supply, you can make a transformer. But the thing is, why AC? Because we want the current or voltage to go up and down, current in the primary coil. So his magnetic field strength also will follow magnetic field of the primary coil also will follow the same pattern. So there can be a electromotive force, voltage on the secondary coil. I am not getting into very high details, but it will be like cosine graph according to if this is sine. But point is, it has to be alternating current, otherwise the flux does not change. Second thing, why do we need a iron core? The thing is, this magnetic field of the coil is like this. It is, in this picture, half of it is wasted. Why? Because this one gets only half, right? Secondary coil. So how to solve this problem? What you do is, you put an iron core here. When you put an iron core, what happens? This magnetic field actually can be bent this way, and this part disappears. Disappear means it is directed into secondary coil. So this way the efficiency of the transformer goes up. So iron core is also important. Electrical connection between primary and secondary coil, no, they are isolated. This has a electric connection, it has nothing to do with secondary coil electric connection. They are electrically isolated. Magnetic interaction between primary and secondary coil, yes, we need input of alternating current, we need let's say magnetic interaction, we need input of direct current, no, we need AC current. So question number 34, answer is B. To do this type of questions, I normally rely on this cliche statement, that is, God is the best creator and nature is the best converter. What does this actually mean? Nature does not give you anything free, you have to work on it. What I mean is, when this coil moves downwards, it will produce some voltage, it means it is producing some energy, right? But nature does not create energy, nature does only changes energy. Of kinetic energy of this beam will be changed to electric energy. Now if you want kinetic energy to change, it means obviously there must be a force backward, right? That's how you change energy. I mean, you go against a force, you lose your kinetic energy, that energy changes into electric energy. Good. Now it means, now let's go to Fleming's left hand rule. Fleming's left hand rule says that there are three variables which are perpendicular to each other, like magnetic field strength, point finger, force on the wire is thumb finger, and current of the wire is middle finger, right? Alright, let's use this one now. Now we know the direction of magnetic field. What is the direction of magnetic field? Into the page. We know the force. Check what is the direction of current. If you do this using left hand rule, right, pointing finger into the page to get a force upward, very good. Current should be from left to right. It means positive charge particles experience a force towards the right, right? They are pushed to the right. So this side will be more and more positive. Similarly, this side will be more and more negative. So most electron highest electron density will be at P and S edge at the end. So I repeat, the beam must have a force to stop its motion. By Fleming's left hand rule, if we have a force, if we have a magnetic field, the direction of current is from left to right. So it means positive charge particles experience force this way. So negative charge particles must experience force, experience a force to the left. So negative charge particles like electrons should get accumulated, collected on PS edge at the end. So answer for this question number 35 is D. Now if you go into resistors, we know R1, R2, total resistance is R equals R1 plus R2, but this one applies for parallel capacitors. We need to understand that if this is C1, if this is C2, total capacitance is C1 plus C2. Opposite, I mean kind of opposite way, right? Now let's think we have two resistors. I use these zigzag lines for resistors, R1, R2, R equals R1 times R2 over R1 plus R2. Actually this equation comes from 1 over R equals 1 over R1 plus 1 over R2. So we know this one. This applies not for parallel capacitors, for in series capacitors. Example, if this is C1, C2, total capacitance is C1 times C2, C1 plus C2. Alright, we need this background knowledge to do this question. Now look at this circuit. They say these capacitors are identical, C, C and C, and there's a power supply. So let's make these two into one. So first part of the circuit is we have only two capacitors now. these two are parallel, so we add them together, 2C and C. Now I change circuit even more into one capacitor. Now total capacitance is, let's say, C dash, C times 2C, R1 times R2, that equation, C plus 2C. So you end up 2C over 3. Okay, this is the total capacitance. Now, so charge equals capacitance, capacitance times potential difference, right? So in this case they are talking about the charge. Okay, so charge in this circuit will be total capacitance 3 times V. So this will be the charge stored in this equivalent capacitor. But now let's go back. So if this is the capacitance, here also 2C over 3, 2C over 3, but again 2C over 3. These two, the charge shares half and half between these two, right? Here and here. So this will be 2C over 3 times half, means C over 3. This will be C over 3. So hold on, I forgot that V. So all of these should have V. Okay. So in this case, charge stored in capacitor Z will be 2C, this one. The other one on X or Y, it will be only half. Answer is C. I added some information here. Before, this is about electrons, right? Electrons are strange people, like they can act like electrons at this level. They can act like particles as well as waves. Now first question is, what is a wave? Particles we can understand, okay, that object, round object going around, that's alright. What is a wave? How do we prove something is a wave? Have a look. If you send something through a gap, through two gaps actually, and if they produce this type of fringe pattern, it means they are interfering. This is called an interference pattern. So if something can do this, this is a wave. And interestingly, electrons can do this also. Second, let's say you send a wave through many gaps, many slits, like a diffraction grating. Then it will produce this type of pattern. Again, this is called diffraction pattern. If someone can does this, this is a proof that this is a wave. So if anyone can show diffraction, it is a wave. Alright. Now let's check about electrons. Let's start with the second one, diffraction grating story. We create a diffraction grating, but not with the real grating. We use a metal lattice. Lattice means a molecular structure, actually a structure which holds nuclei in an organized way. And if you send electrons through this one, interestingly, electrons produce this type of concentric circles. So it means they diffract. So electron can diffract. So this proves electron is a wave. You need this knowledge to answer this question. Now let's think about, again, here we don't send a wave. I am going to draw an electron beam. Hold on, there are two gaps. Okay, I will use the same color. These are the two gaps. We don't send waves, we send a beam of electrons. Now they will produce a double slit interference pattern. Some places there are electrons, some places there's nothing, destructive interference happening. So electron is a wave. That is, this also proves electron is a wave. Third, hold on, I'll get to the question. Now let's read this one. An electron beam is used to investigate the structure of crystals. Of course, this electron diffraction pattern can give lot of information about this lattice of the structure. So that is right. So we use electrons wave behavior to investigate about lattice structures. Second one, an electron beam produces a pattern of fringes when sent through two narrow parallel slits. Of course, we just discussed electrons can also do that job of interference pattern. Third, electromagnetic radiation ejects electrons from the surface of a metal. Of course, that is called photoelectric emission. Let me write the word photoelectric emission, right? That is true, but here A photon comes, interacts with an electron and kicks him out of the metal structure. This is not a wave behavior, this is a particle behavior. Behavior of wave, of electron. I repeat, there is no single slit diffraction, there is no double slit interference, there is no multiple slit diffraction pattern. This is photoelectric emission is about being a particle. So this one cannot be explained by waves. So they ask which statements are explained using the wave-like properties of electrons. These two show that electrons can act like waves. This can show electron can act like a particle. So only first two. So 1 and 2. Question number 37. Answer has to be A. Samples of two radioactive nuclides X and Y are held in a container. The number of particles in X is half the number of particles of Y. Okay, I put that information here. 5, 10. So Y has twice. The half-life of X is twice. Okay, half-life also has a relationship. X has bigger half-life. Now they ask about activity. First thing is to understand what is activity. Activity is given by this equation. So we need to compare activities, right? But lambda is not given. What can we do? But we know lambda is ln2 over half-life times n. Instead of lambda, I write this equation is activity, right? Now I am going to write, so activity of X to activity of Y is ln2 times nx divided by tx ln2 times ny times ty. Check this calculation slowly, you will understand. So in this case, nx to ny is n has half, right? So this, hold on, log t, I cancel out. Nx to ny is half. Ty to tx, half-life of ty over tx is half, also half. Okay, this ends up being 1 over 4. So this answer also has to be A. So question number 38, answer is A. Question number 39 is about something called photoelectric emission, right? What do we know about photoelectric emission? 1. We know photoelectric emission is when a photon, electromagnetic photon, comes and gives its energy into an electron. If that energy is given by HF is more than work function of the metal, so this electron can jump out, right? Second thing we know is that we write an equation which is called which is based on conservation of energy, but not for any electron. We are writing it for the electron on the surface. Example, here we are writing for this one, not for this one, not for this one, not for any of these. Okay, the most energetic electron coming out of the metal plate. Alright, let's write the equation. Let's have a look. The energy of a photon, HF, is the maximum kinetic energy plus work function, right? This stands for work function of metal, and this is the maximum kinetic energy. Why it is maximum? Because that is the electron which needs minimum energy to come out. This is like a balancing sheet. This one equals this one plus this one. Now I am making kinetic energy value as a subject, HF minus work function. Alright, if you take this one as X, this one as Y, this will be the gradient and this will be the y-intercept. Alright, very good. Now if you use another metal with less work function, the y-intercept will change. This is called Planck's constant. This H value is Planck's constant, which is 6.63 10 to the power of minus 34, pretty small, and joule second, and it does, you can find the number in data booklet, but more importantly this never changes, it's always constant. Now how to apply this all the knowledge into this this question? Now this is the graph they plot. So first thing to understand is, for the any other metal also, the line should be parallel to the initial line. So answer has to be A or D. B and C, the gradient has changed. So because we know gradient can't change, it's Planck's constant. Second thing is, as the work function of the graph has decreased, y-intercept has to decrease. Now let's see who has the smaller y-intercept. See, this one cuts y-axis in a smaller number. This one cuts in a very big number, right? Very big means much bigger than previous one. So we have to pick this because work function needs to be smaller. Phi is smaller here than this one. Don't worry about minus sign, I am just talking about the value. So the answer for question number 39 has to be A. Question number 40 is about probability density function. What is that probability density function? I found this picture again from the internet, and let's have a look. What is probability density function? We know that there's a nucleus and electrons can be, we initially thought the electrons are orbiting in fixed energy levels, right? This is Bohr model. We think electrons can be either here or here in these energy levels, right? But that's not the accepted model anymore. Now we think electrons can stay anywhere. They just have a higher probability of being in these energy levels, right? So what does this mean? That's why we use electron cloud concept here. See, higher density and lower density over there. So two things to understand here. One, if you are talking about probability, simple mathematics, probability has to be bigger than either 0 or more than 0. Example, let's think this is my house and I am in my apartment now. What is the chance of you being in my apartment now? However small it is, it can never be minus. So you can say my probability is 0, I am not there. Okay, so probability has to be either 0 or bigger than 0, of course less than 1, because 1 means perfectly 100% sure you are in my place. So let's look at answer A and B. Of course they predict negative probability. Is impossible, so answer has to be C and D. Second thing is probability. I told you it's about electron being in different places. Place means it is about position, it is not about time. See, probability density function is about with the distance or position, the chance of electron being there. So answer has to be C.